Okay, so we're going to get started on our direct proofs. Just generically first, what a proof is. I know it's something that's scary to y'all because the only type of proofs you've had to do are geometric proofs. But a proof in mathematics often consists of a logical set of steps that validates the truth of a general statement beyond any doubt. So proofs are the reason that we can do a lot of the math that we just accept as fact. So when we say 1 + 1 = 2, we accept that as fact, but there is a mathematical proof that has made this the truth. All of our math that we use is proven typically. So let's look at this first example. So an example of what a proof does is take a logical set of steps to make this statement true. So I have to show that 1 + 3 + 5 + 7 plus a whole bunch of odd numbers where 2n - 1 is the definition of an odd number. So the sum of all odd numbers is equal to the sum of a certain number of odd numbers is equal to that certain number squared. So I will show you what I mean by this. The first step is I'm going to write this out and say that the sum is equal to 1 + 3 + 5 plus, and so if we were to like move this backwards, this is the same thing as saying plus 2n - 3 plus 2n - 1, so on and so forth. So all of this to say, I could rewrite this in the opposite order. So this same sum is also equal to 2n - 1 plus 2n - 3 plus 2n - 5 plus ... And if we were to keep this going backwards, plus 3 plus 1 all the way back to 1. So basically I just flipped the order of this, right? So what I can do now is add these two sums together. So what happens when I add these two sums together? These ones end up canceling, and I am left with 2n. Same thing here. The 3's end up canceling. The 5's end up canceling. Every number except for 2n would end up canceling. And this pattern would be the same for however many number of n's there are. So this is the same thing. Let's see, 2s on the side. This is the same thing as saying 2s is equal to 2n times the number of terms that I have, right? Simple math, sure. From there, I know that the sum, 2 times the sum, would be the same thing as saying 2n squared, and then I can divide both sides by 2, and I end up getting the sum is equal to n squared. Now, I absolutely understand that this seems totally ridiculous to everyone. It seems like a lot of extra work to just know something that is true. However, this is the reason why we can do mathematics. And again, I understand you might not be interested in this, but welcome to it. You're in HL Math. Okay, so from here, that was an example of a proof, but a direct proof is a way of showing the truth of a given statement by constructing a series of recent, connected, established facts. So what we do is we identify the given statement and then use axioms, theorems, definitions is the key here, or other things, to make deductions that prove the conclusion of your statement to be true. a lot of fancy words, but basically what this is saying is that for a direct proof, one of the keys is to only work it on one side at a time. So normally if I have an equation like 2x plus 3 equals 3x minus 4, I would like add 4 to both sides. That keyword of both sides is something you cannot do in a direct proof. I can work the left-hand side first and hope I get the right-hand side, or I can work the left-hand side and work the right-hand side and hope that they meet in the middle, but I can't work them both at the same time. And I know that's confusing, but you will see what I mean. So this first example is to show that the sum of an odd and even positive integer is an odd positive integer. So what I will start with is the first step is to identify the given statement. So every proof, every direct proof will start with what they give you. So let m and n be odd and even positive integers respectively. I'm going to speak and then pause it and then write it down because this is taking too long. Thus, m is equal to 2p minus 1 and n is equal to 2s, where p and s are elements of z plus. So what I have done here is used the definitions of odd and even. So the definition of odd is that you have 2 times some integer minus 1. So like think of the odd numbers that you have. 3 is the same thing as 2 times 2 minus 1. 1 is the same thing as 2 times 1 minus 1. Every odd integer can be defined by the function 2p minus 1. Or 2n minus 1 or 2 some variable as long as it is a positive integer. So this last section here where it says where p is an element of z plus, that means it's a positive integer. Similarly, the definition of an odd number is that it's divisible by 2 or a multiple of 2. So we say that n is 2 times some number s. So n is equal to 2s. So I've just used the words and turned them into the mathematical definitions. Therefore, m plus n is equal to 2p minus 1 plus 2s. This can be rewritten as 2 times the quantity of p plus s minus 1. Now, what I'm telling you, what we know, is that if I have any 2 positive numbers, when I add 2 positive numbers together, it has to be positive, right? So I could have 1 plus 7, I could have 1 plus 10 million. No matter what I do, as long as I'm adding 2 positive things together, I end up with a positive number. So now I can make the following statement. I can say since p plus s is an element of the positive integers, then by definition, m plus n is odd. Later in life, you might get to a point where you have to write an extra step in the middle here. The way I was taught to do it is after I say since p plus s is an element of the positive integers, I would have to say it can be defined by the variable k. Therefore, 2 times the quantity of p plus s minus 1 is the same thing as 2 times the quantity of k minus 1, and then say, then by definition, m plus n is odd. But IB is fine with just accepting this much. Now, I know that seems like a lot, but once you get a little bit of practice at thinking about what they're asking you for and what definitions you need to use, it's pretty straightforward to walk through it. What I personally feel like is that the problems are usually a little bit easier if they're asking for a proof. It's more about knowing how to do it. So on that note, the homework problems I decided to give you in partners since we have 2 lessons to do this week. So the first one is Jacqueline and Liz. The second one here is Leonard and Tomas. The third one is Rohan and Andrew. And the fourth one is Knox, Sonia, and Bella. At the bottom, I gave you some additional problems. This is not a requirement to do them, but to only practice one proof is not enough, in my opinion. There is not really Delta math over this. So instead, I've given you a couple of extra IB problems. I would highly recommend doing them. I'm not grading them, but it is your IB grade on the line. I've passed this class. So, yeah. I have these problems as well. I have the answers and can give you guidance. The problem with proofs is I can't really help too much without giving away direct answers, but I will try to do it just one step at a time and see if you can keep going. It is Monday night that I am posting this video. You have me in class tomorrow. And there are 2 lunch periods before you would have to present this problem. So I'm hopeful that if you're stuck, you will come and ask me for help. I will say that I know the first problem, so Jacqueline and Liz on the first problem, you should basically just expand the left-hand side and simplify it, and then you end up getting the right-hand side. So that is the proof. You should only have to do the left-hand side, and then you should get the right-hand side as the answer. For the second problem, if I'm remembering correctly, you have to work the left-hand side and say what it's equal to, then condense the right-hand side, and then you should meet in the middle at the same values. So then you say the left-hand side is equal to the right-hand side, Leonard and Tomas. For the third one, you're gonna need more definitions, Rohan and Andrew, the way I just did that last one. So you'll need a 4-digit number to be divisible by 3. And then the sum of the digits. So you're going to have to define each digit as a variable. Once you do the first part, that's like you assume the first part to be true, and then you prove that the other side must be true. Okay, and then the last one, it uses, I'm pretty sure that's geometric sequence. You're going to need the definition of a geometric sequence to do that one. Hopefully that's enough to get you started. But again, if you need help, please come see me before Wednesday, like 5 minutes before it's due. Yeah, if you have any other questions, just let me know. I think I have the answers to all of these. I definitely have an answer to these first 4 that are your homework problems. Great.